Hi everyone, our project is called Reach, and it's a Bluetooth 5 Internet of Things host gateway. I'm Alexis, and I'm here with Lizzie, Ryan, and Jake. We'll all be doing software development throughout this project, but we've also taken on additional roles. So I'll be project managing, Lizzie's in charge of client correspondence, Ryan will be our technical liaison, and Jake is our resource manager. So our client for this project is Gateworks. A little bit about Gateworks. They are a design and fabrication facility centered here in SLO, and they specialize in developing embedded single board computers. What sets these apart from other customers is that they're designed specifically for like rugged industrial military applications. So our project is really meant to like emphasize like the capabilities of the Gateworks hardware and combine a bunch of pieces into like a really effective system. And the big takeaway for our project will be the documentation for how we created our gateway, which will be featured on the Gateworks website for Gateworks customers to build their own IoT gateways. Oh, and our main touch or our main connections at Gateworks are Bobby Jones will be he's the organizer. He's a software engineer, and Ron Eisworth is the VP of sales. We're also in touch with him. And then we have Cale Collins, who's a field applications engineer, and he'll be the technical support for our project.
So a quick overview of our project. Essentially, we're going to use the Gateworks Ventana single board computer to read data from whatever tags a customer chooses and upload that data into a Microsoft Azure cloud database. And we're motivated for this project to show that Gateworks boards can support Bluetooth 5 as another capability and feature within their resources. And just a quick thing about Bluetooth 5, so it has a longer range and higher data rate than previous iterations of Bluetooth. So some use cases, so as you can see here, equipment tracking, livestock monitoring, factory levels and ammo sensors. So for example, there's a wide variety of uses for this project, but for example, one is a fuel tank where they're trying to monitor the level within the tank. And so they can use our tag, and that data will be sent to the Gateworks board over Bluetooth 5 to save the time of someone having to go all the way out to the tank to measure the levels.
All right, here's a general system overview of our project. Up top here, we have our Gateworks single board computer. That's going to be kind of the main hub for all these tags. To communicate with these tags, it has a PCIe expansion card that is both Bluetooth and cellular data enabled. It'll use this card to take all the data, read all the data from the tags, and then eventually relay that data back to an Azure Microsoft database, which can be accessed remotely from any home computer. Here is the hardware we will be working with. This is the single board computer I was just talking about, and then this is the PCIe expansion card, like so. The board itself will be running an Ubuntu operating system. For most Gateworks applications, they use what is OpenWRT, which is just an open source RTOS. For this one, though, they felt we'd be a bit more familiar with Ubuntu, so they gave us the option to put Ubuntu, instead of on the onboard flash memory, onto an 8 GB SD card, which will then serve as our operating system, root file system for this project. PCIe expansion port is on the reverse side of the board, like so, and this card will plug in there. And yes, so this board is also, it takes a 12-volt power input, and it will also be capable of providing an Ethernet connection if you want a wired connection to our remote database.
Cool. So our goals, this is the Gateworks wiki that Alexis talked about earlier. Their end goal for this project is to go on that wiki and attract customers to buy their hardware. So with that in mind, it's really important for this project that we write great documentation that customers can follow, and documentation and code that allows for replication, because they're going to take this code and use it for their own projects. So, next slide. With that in mind, the customer requirements are centered around demonstrating the capabilities of the GateWorks boards. That means the Bluetooth 5 capabilities specifically for this project, but why customers should buy GateWorks boards as opposed to other boards that have Bluetooth 5. So we're talking about their, like she said, the rugged capabilities and things like that. So we came up with a couple of engineering requirements based on those.
So our first engineering requirement is that we want the system to be pretty low power, just because we want it to be low maintenance and last a while. We also need a cloud-based database, and of course the software needs to both pull and post data from the Bluetooth tags in the system, and also a really helpful web portal so that customers can easily see the data that's been collected and analyze it. Also, because as Lizzie discussed earlier, there are a wide range of use cases for our project. So we wanted to keep functionality in fairly extreme temperatures, just if it's outside, on a farm, or in a warehouse. So we also, of course, as Jake mentioned, need extremely high quality documentation. We want to make sure that our system can collect various types of data. So this could be like RSSI, fuel levels, ID codes, amongst other things. And our system needs to support actively adding and removing Bluetooth tags, and adaptable to just different types of Bluetooth tags, so customers can use whichever generic Bluetooth tag that they would like. We also need to protect against data volatility. So this means as soon as data is collected from the tags in the system, we want to push it up frequently enough so that if power is disconnected, we won't lose any data. We also need to make our system as adaptable as possible. As we've stressed throughout this presentation, GateWorks customers will be replicating our project. So for their use case, they need to be able to just kind of go in, see what we have, make the changes so they can make it apply to their system and have it be a quick and easy process.
Okay, so based on those engineering requirements, we came up with a few software solutions, and then we used this decision matrix. The decision matrix is heavily focused on adaptability, as we've been stressing, because it doesn't matter how good our product is if the customers can't use it and they won't buy GateWorks boards. So we came up with these 4 solutions, and then we rated them, and then we took pieces from every solution to come up with a final software solution that looks like this. It's a little scary, but I'll just quickly go through it. The initialization, it just pulls data from the cloud as far as what kind of tags they're using. So the idea of this is that we could make it so the customer goes in and hard codes what kind of tags they're using, what kind of data, how many tags, things like that. But we want them to be able to easily just add it to their database and have it pull on boot what they're going to do. And then its base functionality is just pulling tags that it knows about that it's been paired with, and then pushing that data to the cloud. We want to support an ability for the customer to choose the frequency that they push to the cloud. So whether that be as soon as they read the tag, have it available in the cloud, or post once a day, once a week, depending on their design. And then finally, we want to be able to add new tags to the system without rebooting it. So during operation, it could be somewhere hard to reach. So we want them to be able to easily add and pair new tags and then have the system be notified to pull that data from the cloud.
Yeah, so some quick things. So we spent pretty much this entire quarter doing a Bluetooth 5 proof of concept on similar Nordic semiconductor boards so that we can show GateWorks that this does work. And then from there, we started getting the GateWorks boards working, and our goal is to port that code over to that by the end of holiday break. And then next quarter, we're going to work on creating the Azure Gateway and getting it integrated with the boards. And we're going to try and get that done by mid-March so that we have a lot of time to test and get everything working up to their specifications.
Questions? No? Thank you, Bruce. No questions?
Question. So how many tags are we?
That's as many as possible. Yeah.
So there's some standardization between the tags, but a large part of it is just what the data looks like. So we're hoping to have some way that they can add what their data looks like into that, the data that it pulls from the cloud when it boots up, if there's a way that we can have them specify what the data is going to look like for their specific tag, that would be awesome, because then we could support a large variety of tags, but we're still working on
Am I right in saying that the tags can provide more than just their ID? In which case, how can they access the data on the cloud?
that. The tags,
Yeah.
we wouldn't have designed it to be that way. Because they're just, the idea of this system, at least at its core design, is just to, the hub is just reading the tags. The tags aren't coming to the cloud, and then the hub is what's connected to the cloud.
So the tags themselves will be like sensors, so they'll read data from like an oil tank, and then they'll send that to our hub. And our hub should send that to the database, where the customer can view that data using the Amazon web portal.
So the database is going to contain the data provided by the tags.
Yes.
So the answer is kind of yes.
Kind of.
The tags.
Yeah.
Have you chosen or thought about an application for tags? I know you mentioned a few of them.
Like something flashy, you mean? Yeah, we're still working on that, because as we talked about in the customer requirements, we want something to excite the customers that might want to buy a Gateway board. But our main deliverable is something replicatable and simple that the customer can apply to whatever their solution is. So we're trying not to get too focused on one specific exciting solution, even though that might be what we want to do, because that would not really be fulfilling what Gateworks wants from the project.
I think maybe in the future, like if once we get the whole system working, I was thinking we could do something with like colored lights, showing like the color of the lights, if they change or different things like that, just to send, like get a sense of like almost real-time updates. So, but some sort of flashy idea.
Great. Is there a reason you chose Azure, or was that
That was part of Gateway specifications. Apparently they have some sort of contract with Microsoft.
That's a great question, though.
So all of the hardware that we have here was just, those are constraints from GateWorks. We have to use this board, this PCIe adapter, and Azure as well. So
Yeah, it's a heavily software-based project. Any other questions? Jacob? Usually have one? No? Okay.
All right, thank you.
Yeah.